and today we're talking about Salesforce's multi-tenant architecture. So basically subtitled, how we do the magic we do, because in my personal opinion, what we do is pretty much magic. It's pretty cool stuff. So you will have seen this slide 1,000 times before. It's our safe harbor slide, but basically what it says is, please base your purchasing decisions upon current technology, not about any futures. The majority of this presentation is about current technology, although I do have a future slide in there, so I will tell you about that when we get there. So let's move on. The Customer Success Platform, it's what you're all using if you're Salesforce customers, or what you will be using to enhance your customer's experience if you're currently a prospect. And as you can see, it's based upon a whole bunch of stuff. We have our complete CRM as the application suite on top, with our open ecosystem with all of our partners, across our scalable metadata platform. And that's the part I'm talking about today. It talks about the data and the objects, the mobile user interface experience, the collaboration capabilities, our analytics, workflow and identity. All that sort of stuff runs on our multi-tenant platform. It also provides very quick and easy development application. So it helps you tailor the Salesforce application to suit your requirements, and also makes it very robust, because Salesforce does 3 major releases a year. And the way we can do that without breaking any of your technology is actually because of our multi-tenant architecture. And we'll cover that off a little bit later on, actually, how we do what we do. And it's all running in our trusted multi-tenant cloud. And multi-tenancy is quite important, because depending upon who you are, multi-tenancy means different things to different people. So multi-tenancy in an Amazon world is a virtual machine. And that's a great way of doing infrastructure as a service. You get space in a data center, you've got to install the operating system, you install the software you want to have, you write your software, you deploy that, you then upgrade it, you do your patching, you do everything else yourself. All the security issues and everything all taken care of by you. Versus software as a service, which is what we do, which is we take care of all that for you. We deploy all the hardware, we deploy the software, we do the patching, we do the upgrades, we do everything for you. And because of that, it's a much easier service for you to worry about. All you need to worry about is just looking after your customizations, your configuration to make your business do what it's got to do. So let's move across and see actually what we're talking about with multi-tenancy in Salesforce terms. It's one cloud with many customers. So what we have here is a group of shared elastic services. And we're talking about elastic, meaning it can expand and contract when required. So there's many, many things that Salesforce does on your behalf. Now there's one primary data store per production instance. We'll talk about what an instance is later on, but what happens here is you have multiple customers running inside of one piece of technology, one Salesforce instance. This instance contains all of your data, it contains all of your configuration, it contains all of the other people who run on the same instance, it's their stuff as well. So an instance is like NA1, NA34, EU5, AP1. It's your instance of Salesforce where it lives. We have about 50 of these today, actually more than that today. We're pumping out more instances as we keep growing exponentially. So it's a bit of a cookie cutter. We've got a setup whereby we can just create a new instance and deploy it, and all new customers start moving on to that. These instances are also only kept half full to make sure we have scalability, to make sure that when you grow, when you become successful, we can take your load and actually keep expanding and going with that. Now, there's one primary data store. That's quite interesting, because people start thinking, well, hang on a second. If I'm running on Amazon, I've got my own database and I've got all my stuff in there. That's great. That's true. When you're running in Salesforce, we have one database table with all the data living inside there. All of your data's in there, and everyone else's data's in the same table. We'll talk about how we keep them separate a bit later on, but that's actually part of the power of the Salesforce platform. We can grow and scale to suit your requirements because of that technology. All the data is segregated by the customer, because even though it's in one table, we've got to keep them separate. So you don't want to see someone else's data and vice versa. And if that actually happens, we're in serious trouble, right? That's called data leakage. That's not a good thing. And it never has happened, never will happen. Otherwise, I won't be standing up here anymore, because we won't exist. So all this is deprecated upon what we call an org ID. So whenever you have your own version of Salesforce, we call that an org. And an org ID is a unique 18-character code which is attached to your particular org. And every record in this data table has got your org ID as part of the primary key. It also is part of the primary key for our metadata tables, and we'll get to those a bit later on. We also look after disaster recovery as well, so obviously your data is living in our cloud, and we want to make sure that if and when, heaven forbid, San Francisco gets a bit of a shake, and the San Jose data center goes offline because of a bit of a shake, if you're in San Jose data center, we want to make sure that you're kept up and running, so we'll have a disaster recovery in a geographically disparate area. So every copy of your data is actually stored in more than one data center. We'll talk about that a bit later on as well. If you use platform encryption or if you use our standard encryption that we supply as part of Salesforce, part of your keys are also stored in your org as well. So each org has got its own unique encryption keys, and that's part of the platform that we keep as well. So all of that's kept in this big data stack, and we move on from there. So what actually is an instance? Like I said before, it's basically your shared database. It's got metadata tables, it's got pivot tables, data tables themselves. There's a huge metadata cache. Now the metadata cache is where we keep all of this metadata stuff in memory to make it very, very efficient. Because what we do is we actually generate every page you see on the fly. There's no pre-caching, there's no pre-compiling, it's all done on the fly every single time. So whenever you go to look at a page in Salesforce, we'll pull the metadata out of your instance, we'll combine it with your security ratings to see what fields you can see and that sort of stuff, and we'll build the HTML on the fly every single time. So if your administrator changes your permissions so you cannot see a certain field and you refresh the page, you can't see it, it's gone. We do not pre-compile anything. Now, that sounds pretty impressive, right? We rebuild every page every single time. We do that in under a quarter of a second for every page on average. That's pretty cool. Now to find out how quick your page actually runs, if you go to your browser and do a view source and scroll to the bottom, the last line will tell you how many milliseconds it took to run inside a data center. So that's a pretty cool bit of knowledge to know about as well. Now, for those of you actually taking photos of these slides, they will be available in the chatter group for the presentation, so you will get a copy of them as well. What else is also in the instance? Well, we have bulk data processing, because obviously there's not just you working in your version of Salesforce, there's a whole bunch of other folks dumping stuff in the same instance. So the capability to actually load in tons and tons of data regularly and very efficiently is there. We have a multi-tenant aware query optimizer, and we'll cover that off in a little bit later on. We generate the app at runtime, like I mentioned, but that's also for the API. If you add a new field to your Salesforce object, one of your objects, for example, the opportunity, you add a new field to your opportunity, so maybe you have the SAP ID you want to store in there. As soon as you do that, that field is available to the API instantly, without you having to do anything. That's part of the beauty of the multi-tenant architecture. And obviously a full text search engine. So at the top of every Salesforce page, there's the global search. That searches everything that you can see, and that's a key differentiator. Everything you're allowed to look at, it will be searched for. So if you can't see a field, and you search for content that's in that field, you can't find it, but your colleague who has access to that field can do a search and find it. So actually it's security-aware searching, which is quite powerful. And then we have we have common application screens. So Salesforce has got the setup tree and that sort of stuff, which are all common amongst everybody. But we have tenant-specific screens. So we have your changes you've made to the Salesforce screen. So you've always added some fields, you moved things around, added some page layouts, etc. That's all yours. And lastly, we have our objects or tables. And that's where we have the virtual application components. So when you log into your version of Salesforce, it's going to be very different to someone else's version of Salesforce. But it's all running on exactly the same bit of kit and works exactly the same way. So multi-tenancy is actually very important for our R&D team as well. One version, not quite true. We have two versions of Salesforce, this one and the next one. That's it. You're never going to be left behind. The beauty of Salesforce is every time we do a major release, 3 times a year, you get that release with all of its new improved features. If you don't want to take some of those features, that's fine. We will auto-enable some features. Features that do not change the user interface experience or how the function of the actual application works, we don't turn them on. So for example, you've seen the Lightning experience. Everyone knows about Lightning experience. That's actually going to be enabled but not turned on in all your Salesforce instances. If you want to use it, you've got to turn it on yourselves. So that's a feature that your admins can take. So all of these new enhancements we do, it's actually up to the administrator to actually turn those features on. But the good thing is, when we fix a bug, we fix it for everybody. That's one of the nice things as well about our multi-tenant platform. You don't have to worry about waiting till someone actually comes out and actually does the deployment on your hosted version, or heaven forbid, if you get a CD in the post every couple of years with a new version on it, that's not really the good way of doing it either. So automation is also very key. We don't just do manual testing. Obviously, the programmers, they do their own testing manually, and that's sort of great. But every time they do a commit of data, it runs 260,000 tests upon that code every single time they do a deploy. So all the techies checking in code that actually runs our Salesforce instance, all these tests are run every single time. You may be wondering how we run your tests. Well, when you write Apex, the programming language that runs inside of Salesforce, you must write test classes against that to make sure that it does what it says on the tin. And these test classes are actually very important to us. What we do is we take a copy of the production version of Salesforce, one instance, with all your tests in it. We'll take it over to our testing environment. We'll anonymize all the data, so nothing's going to be in there that recognizes your stuff. And then we run your tests. Before we do the upgrade, run your tests again. If the outcomes are different, we've got a bug, we've got to fix that. So we make sure that all your tests work between releases as well. That's how we can guarantee that when we do a major release, nothing breaks. Guaranteed. Your code will work exactly the same way as it used to work. The Visualforce pages keep working. The API still works exactly the same way as well. Nothing breaks. If it does break, it's a bug, we fix it. That's the beauty of Salesforce. And then instance architecture, like I said before, we have multiple instances, over 50. So what we actually do is we do a staggered release. So we've already done the upgrade for winter on some of our sandboxes already. So some of you who already will be seeing the new winter release coming out. Next week, we do the first release. We do another release 2 weeks later. So actually, you'll be seeing in your Salesforce instance when it's going to be upgrade time soon. If you want to know when that's going to be, we do these 3 releases a year. These releases are always advertised on our trust.salesforce.com website. And there's a calendar out there telling you exactly when the releases are going to happen for the next year or so. So you can see exactly when we plan on doing maintenance, when we plan on doing our upgrades. And it's scalable across all sizes. So if you're a mum and pop shop with only 2 users, that's great. Or if you're someone like Coca-Cola or Barclays Bank or people like that with a huge number of users, you can use Salesforce as well equally. That's the whole beauty of Salesforce, very democratic. We have very big customers and very small customers. They both get to use all the same technology, the same security. And then predictability. Like I said, 3 major releases a year, but we do bug fixes every week. And you don't even know about the bug fixes. We just pop them into production, you don't even know about them. It's one of these things we do on the fly. Because all of our patches are designed to be non-intrusive, they just fix up some issues and away you go. And lastly, adaptive delivery methodology. What we did originally was we used to write in waterfall approach. So back when Salesforce first started, we had, write the specs, get them signed off, do the code, deploy, write the specs, do the code, like everyone else used to do, right? And we had a bit of a problem when we started slowing down our release cycle and the bug rates went up quite high. So what we did was we decided to change the way we do our methodology, and we now use Agile. And that's been happening for many, many, many years now, before I joined 7.5 years ago. It's been about, I think, 10 to 12 years we've been doing Agile development. So that means we can do these 3 releases a year and make sure that the quality's up there, make sure actually we get the features out that you want and need. And it makes our developer guys much more efficient. So then, click, thank you. So the key architectural principles, what actually do we do to make sure that we can scale this well? Well, we have stateless app servers. And what that means is when you make a connection to Salesforce, you talk to this web server process, this app server process, this search server process, this database server process. And then it does the work for you, gives you back your page, and then promptly forgets about you. It's all stateless. The state is kept in the database structure, which means that when you come back in, you can use a different app server process on the same instance, and it will just scale automatically. It means that we can shut app servers down. If they have a problem, we can just bounce them, and it won't actually cause a problem to anybody actually running. We use a database as a system of record, so the ability to store this data securely, robustly, and back it up, etc., is all there for you as part of the standard process. We don't do data definition language at runtime. Now, inside your version of Salesforce, you can create a table and that sort of stuff. That's fine. And when you do that, it looks to you like you're creating your own relational database, right? Well, you're not actually. All you're doing is creating a couple of rows in a table, and I'll talk about that a bit later on. Now, the trick is, if we actually did Oracle database table creates inside of our Oracle database under the covers, it would lock everything up and make it basically stop. There's no way in the world we could support that. That's why we have our metadata approach actually to make this work. All the tables are partitioned by the org ID, like I mentioned before, and these keys are very smart. They actually have some data in them. So for those of you who are Salesforce administrators or current users, every time you go to a Salesforce record, you see the URL. It's actually got an 18-character field after it. That actually is the row ID of that object you're talking about. That row ID, the first 3 characters, actually is what object it belongs to, what table. So 001's account. I forget, 005's user, etc. So these are the object names. So these primary keys are actually clever. They contain data as well as information, so it's quite powerful. We have polymorphic foreign keys, which means we're able to link tables together without actually having to worry about having exactly the right sort of naming conventions in there as well. Denormalization is interesting. Those of you who studied computer science will have known of third normal form. It's the most pure database structure out there. However, it's basically useless. It doesn't work particularly well. So what you need to do is creatively denormalize. So basically what that means is you copy data elsewhere. You have replicated data. That's normal. Third normal form means no replicated data. We want to have replicated data to make it go quick. So that's the whole point. You've got to normalize to make it correct and then denormalize to make it go fast. And we do that very well. And we use a lot of pivot tables. We'll talk about those in the next couple of slides. And our techies are some of the most skilled Oracle programmers out there. And they use every trick and tip that they can do to actually make this thing fly. Considering we've got some stonkingly great Oracle systems out there, we make sure this thing really works. We're one of Oracle's biggest customers, and they get a lot of money off us every year. So that's one of the reasons why they're bigger than us at the moment. Just wait. Just wait, we'll see what happens later. We're gaining quickly. So then let's have a look at actually how these things work. So this is the metadata, data, and pivot table structures that we use to store the information inside of our system. So if you see here, we have the objects on the left and the fields. We have the data itself with some clobs, that's character large objects. We'll talk a bit about those as well. On the right-hand side, we have all of the different pivot tables, so indices, unique fields, relationships, most recently used indexes, the fallback indexes, etc. Now, a character large object are your long text fields, so your rich text fields, your long text fields, and those types of things. And your data is just a current one big lump. Let's go through this in detail now. So if we look at the objects themselves, the object table contains the object ID, the org ID, and the object name. And that's basically what it contains. If you think about it, that's all it's got to do. So when we have a look at your list of objects, we can do a search by your org ID and pull them all out. There you go. Now, the object ID is unique to actually link across between the two environments. So if you look at the fields on the right-hand side, the field ID is used as a unique key. It's got the org ID and object ID, along with the field name, what the data type it is it indexed, and what's the field number. Now, keep the field number in your head because we'll come back to that in a second. And then on the data side, what we have is a global unique ID. That's that thing you see on the URL. That's the global unique ID, followed by the org ID, object ID, the name, so that's your key field that you know when you create a Salesforce object. And then we have value 0, value 1, value 2, value 3, value 4, and they're all character strings. So the field number in the field refers to which value it is in the data table. So in fact, you could have field 1 in your fields actually being stored in value 73. Field 2 could be stored in value 50. Who cares, right? Doesn't matter where it's stored as long as it works. So that's how that works with our data heap. And here's an example of what the data heap looks like. So on the left, we have a global unique identifier. We have an org ID, object ID, and then we have value 1. Now, if you see, value 0. If you look at value 0, the first two lines are actually a text string, bless you, up and flat. The next one is a date. The next one is a number. Now, we store everything in this data table in a character string. Every single thing stored in a character string. Date, times, everything. Now, the trick is with that, it's like, that's a bit of a pain. How do I get it back into a number, or how do I get it back into a date? We do those conversions for you to make them work the way they should work. And that's going to slow things down. It doesn't really. We've got some really quite clever developers who know how to make this thing fly. So that's how that works quite nicely. And then how you do indexes, though, if you think about it, having everything stored as a character string makes sorting a bit challenging, right? How do you sort -10 and 1 and 7? You tried to sort numbers in alphabetics, it doesn't work, right? So what we have to do is create this thing called an index table. And what we have is, on the left-hand side, we have the index themselves. So it's the org ID, object ID, and field num as the key, the global unique identifier, which links back to the data table, and then we have 3 fields, string, number, and date. What we do is we copy the data out of that column and stick it into the appropriate field in the index table. So now then we can use the Oracle indexes to pick it up and make it work. So we rely upon the Oracle indexing under the covers to make that happen. And then unique fields is exactly the same, except it's now a unique index, not just an index. So that's how your uniqueness can work as well. We then do things with relationships. So this is your parent-child and your lookup relationship as well. So if you think about it, the data table actually has all the records in it, so therefore it's actually self-referencing. So the challenge then becomes, how do you make those things reference? Well, what we have is when you have a lookup field or a master detail, when you look at the page, it's got like the account has contacts, right? So in the contact object, there's actually a field called account. That stores the ID of the account record that it relates to. So these relationships are actually defined in this relationships table. So the org ID, object ID, the global unique identifier, and relation and target object. So you're saying, is it a lookup, or is it a master detail, or is it whatever? So you have a relationship there, and then we have the target object. So you're able to do the cyclical links via this one particular table. And it's actually indexed both ways. So you can either go from the data to the parent or from the parent to the child. So you can actually do it either way around. And that's how that works. Now, all the data and the metadata that we have is partitioned to improve performance. So if we have 8 gazillion rows inside the data table, that's not going to be very efficient to use, as we all know in database terms. So what we do is we partition it using a hashed calculation. A hash calculation is just a mathematical formula that takes the org ID that you have and ends up with a number between 0 and 31. So we have a 32 space hash. And that hash is a one-way calculation. So you take your org ID, come down to a number, and that's always going to be the same number no matter what the org ID happens to be. But obviously there'll be collisions. So roughly 1/32 of every orgs will actually be in this particular group, and other 32nd will be in this group. So we try and spread it out evenly across the whole lot. We have separate connection pools to point to physical hosts. So what we have is part of your session ID that you have when you get to log into Salesforce. It's a bit of a hint actually as to which bit of hardware you should sort of aim yourself back at, which app server you were talking to before, because it's got a memory cache and that sort of stuff, and if we can keep that working, that'd be great. So we try and put you back on the same app server, but it doesn't have to work that way, so make it a bit more efficient. So we do these little tricks and tips, it's too early in the morning, to actually get this thing working performant very well. Now the app tier is also dynamically partitioned. So like I said before, you've got the database being partitioned, the app tier as well. So actually we will put you back into the appropriate app server pool depending upon your org ID. Now this metadata cache is quite interesting. We try and keep the metadata in memory as much as possible. Otherwise, when we actually run the system, it'll be quite slow not having the metadata cache there. It has to go look up the data all the time. So this metadata cache is quite important. However, when you add a new field or you add a new index or do something else to Salesforce, we've got to delete your cache and reload it again because now it's invalid. And that's non-trivial, as the techies like to say. It's not easy at all. So there could be a whole story just about how we do that, but that's pretty cool stuff. We don't cache the data as such in our metadata layer. We use the Oracle data, actually the Oracle database to cache all our data when we're actually accessing that as well. But we have a metadata cache, which is quite clever. Now moving on, actually we give you a whole bunch of stuff for free. So inside the Salesforce environment, we give you declarative point-and-click development capabilities. We give you bulk processing. We give you a recycle bin, which is quite unique. A full text search. We give you some very powerful bulk data manipulation stuff. And we also have very powerful web service APIs. That's all generated for you as part of the metadata layer. So when you come along and actually create an object in Salesforce, you actually define the label, the plural label, that sort of stuff. And that's what gets stored in our metadata tables. And the field history and that sort of stuff as well. We do all this sort of thing to actually make things work easier for you. Things like the tracking field history. All we do is tick a box, and that will then automatically allow you to keep history of the 20 fields inside your Salesforce record that you want to keep for auditing purposes. If you want more than 20, there's a feature you can purchase from Salesforce that lets you store more than that. But at the moment, it's 20 on that particular standard setup that we have. Now, if you did that in Oracle or SQL Server or something else that you do on-premise, turning on the audit trail feature slows the system down quite dramatically because we've got to start taking 2 copies of everything and seeing what's going on. It slows everything down quite a lot. So with Salesforce, that's not the case at all. You can turn that feature on, it doesn't slow you down 1 iota. We do some very powerful things behind the scenes to make sure that works very, very efficiently for you. Even though we're using Oracle under the covers, we can actually make it faster than Oracle, which is pretty clever stuff. A bit of black magic happening there. So that's how we do our very powerful stuff to help you build with using the metadata tables. Now, validation rules are quite interesting as well, because these validation rules have to fire when you do a save of a database. They sort of have to be available to the whole processing of the engine. And these are just calculation fields. So those of you who have done this before, you know it's pretty simple to build these validation rules. They're very similar to an Excel query, and you sort of just put in some formula values in there, and then if it's true value, then it's actually an error, and you put the error message out. Now the good thing is, if you actually build this validation rule in your metadata, it will work for the user interface, also work for the API. So as soon as you save it, it's now valid and starts being used. So if someone comes in via the API and tries to do something, it'll actually fail as well, versus just coming via the user interface. So that's where it all goes through the same pipe. This is the whole beauty of this. This metadata platform is used for everything. So we don't have any backdoors going around the edges, which is why this just works and makes life a lot simpler for everyone concerned. Now you think about it, all the things that have to happen when you do a save, this is part of it, but it still gets done in under quarter of a second, which is pretty cool. So then moving on to roll-up summary fields. These are also not very easy to do. Your roll-up summary field is where you have some form of calculation done across the records that are the children to the parent. So you may have like an expense header and expense lines, and you want to have a total of all the expense lines based on airfare and train fare. So you want to add up all the values for train fare, for example. Now, in the old way of doing that, i.e. when you had to write code back in the old days, working on SQL Server, Oracle, whatever, you have to write that either as a database trigger or actually put the logic in your code that you have for the front end. Well, with Salesforce, you actually build it in the definition of the tables, and we do all that stuff for you. So how do we do it? Well, we actually, behind the scenes, we'll actually do all the calculations, we'll store the values for you, but occasionally it can get out of sync. Actually, we will do a background refresh automatically as well for you to make sure that comes back into sync as soon as we possibly can. And you may actually notice a little hourglass appearing occasionally where the field should be because we're doing a recalc for you. But this is actually very powerful, and it's built as part of the platform. These are part of the things we do for you to make your life easier. Think back to the old days. When you create an object table in SQL Server or Oracle, you have to then go build the API. You then got to go build the screens around it. You've got to put the business logic in somewhere. With this, you can do most of it with point and click. There's no code required, which is a very powerful feature. Now, as I said before, the actual bulk processing is quite powerful as well, because whenever you save stuff into Salesforce, this is how it actually does its work. Now, when you're just typing in a value and hitting save, that's just one record being updated. When you use the API, it could be 10,000 records being loaded into your Salesforce instance, your Salesforce version. So how does that work? Well, with database triggers, what we actually do is we don't pass every record to the trigger individually, because that'd be very inefficient. That's what Oracle and SQL Server do. What we do is we'll actually grab 200 of these records, put them in one lump, and pass them off to your trigger. So your developers have to write code that's what we call bulkified to cope with that amount of data. So actually work through that sort of stuff. So here's an example. We want to create 10 records. We want to create some data in Salesforce coming in, and it's a big lump of data. So we go to create it. We run the before triggers, the pre-triggers, and a couple of errors happen. We then validate the rows. More errors happen. We then actually save the rows to the database, and then we run the after triggers. And then we actually execute the workflows, calculate the summaries, and then update the order info. And all of that happens on all those records. But if there's some errors, they'll slip out to the side. So they actually won't get processed. But the other ones will. So it all happens as part of the bulk optimization. And we've gone through that many, many, many times, very, very quickly to make sure that this is speed-tuned beyond belief. People spend so much time making sure this really works quickly. It's not funny. Because obviously we want to make sure that data gets into Salesforce and out of Salesforce very, very quickly. And the data definition, we actually do a lot of stuff under the covers as well. So even when you load data into Salesforce, we'll actually do many things behind the scenes to make it work more efficiently. Like we sort all the records by primary key before we try and save them. And that's actually an interesting thing. If people out there today are using our data loader or our partners' data loaders to put stuff into Salesforce, to make it more efficient, sort your data before you put it into Salesforce. Actually work much better and will stop locking happening. Those of you doing a lot of bulk data processing, there's a great blog up at developer.salesforce.com that actually will go through and explain how to do bulk data processing much more efficiently. We operate in tables in a deterministic order. What that means is we'll actually go through and we'll always do a save to the tables in a certain order, and we'll do it every single time the same way. The reason we do that, it stops what we call deadlock, where someone tries to do a save on the child and someone saves on the server, and they've got a lock happening, we can't actually unlock it, so we sit there fighting each other. So if you always save it in the same order, you'll never get that happening. Well, it minimizes the effect of that, so it makes it a lot easier to work. When you change data types, so let's say you have a a number field in Salesforce and you change it into a character. How do we do that? Well, we will pick a blank slot in the data table and we will just flip it over and make it work that way. We reallocate the slots. We defer the calculation on roll-up summary fields just to make sure that it can be done afterwards to make it easier, and background processing for mass changes. So for example, if you load in 20,000 records into Salesforce and it's finished doing the load, it may still be being indexed. So you may not be able to find those fields straight away if you go back to the global search. So just be aware of that. The search engine is not instantaneously able to search for every record you've just loaded up when you do a big bulk load. If you just load one record in, that's probably going to be fine. When you load in 20,000 records, it may take a couple of minutes to actually come back and actually be able to be searched. Now, the recycle bin is quite intriguing. Recycle bin is normally something that happens on an operating system, right? You put it in the trash, oops, get it back again. That's quite cool. And you can get that for free. So when you delete a record, you don't actually really delete it, you're just marking it as deleted, and it goes in the recycle bin. It'll live there for at least 12 hours, I believe, and at most 3 weeks. And it will ripple out depending upon how many more deletes you do. You can bypass this by using the hard delete via the API, actually, to make sure the records just vanish straight away. Now, we also will, if you delete the parent, we'll delete all the children, they all go in the recycle bin as well. And you can undelete them. That's okay, that's pretty cool. You undelete, come back, that's fine. The trick is, what happens if we change the database structure? So let's say you have an opportunity, you delete one, you then add some more fields to the definition opportunity, you can still restore the one that was before back. That's pretty cool. That's quite hard. We'll get to questions at the end if you don't mind, please. We actually are recording, so we'll get you to speak at the stand as well. And then when we actually able to, you can also, when we delete columns, so say you want to delete a column in Salesforce, delete a field, that'll also get put in the recycle bin. You can get it back as well. So we do it on metadata as well as data as well. So it is a very powerful feature in Salesforce and something that saves my bacon a few times. So search, we talked about search a couple of minutes ago, but search actually is anything but simple. So what we do here is on the left-hand side is your primary instance of Salesforce, and it's having all this data being stored away happily inside the Oracle database. We take a copy of all the data that you want to search on and actually stick it into a search index, and that's the top left-hand, that one there. That's where we put that index search. Now we back up that index as well to make sure it's nice and safe, and we copy it across the network to your failover data center as well. So all this is done for you, and at the moment, we're using Lucene and some home-written stuff as our search engine, but we're moving towards using Solr, S-O-L-R, as an open source search engine. So that's going to make life a lot easier for us internally, and it'll make it more efficient for you guys under the covers as well. So Multitenant Search is quite powerful. Now, those of you who were here last year, I showed the same sort of slide, but with very different numbers. We've grown 79% since last year in turnover time. This is every quarter. We're doing over 225 billion transactions. We're doing over 3.5 billion a day. And around about 30 to 40% of those are API calls coming inbound. So we're doing over 1 billion API calls into Salesforce a day. We don't count the outgoing ones. So that's just monster. And if you look at that scalability on the left-hand side, where we have so many more transactions per quarter, look at the response time on the right-hand side. It's going down. That's pretty impressive, right? We're doing much, much more stuff, but it's just going faster and faster and faster. So hopefully it gets down towards 0, but that's never going to happen. But I think, quarter of a second, that's pretty cool. I can live with that, right? It's not too bad. So the capability is actually quite powerful there. And we do a lot of stuff to make the optimizer work as well. So query optimization is something that's very, very important. So let's go through and actually see how this works in detail. So what we do is you type a query in or have Apex do a query for you, and what we'll do is we'll actually do some pre-queries on the database under the covers. We check to see what fields you can see, what records you can see, and also see what you've used with the filter selectivity. So it says filer, I should say filter, my apologies about that. So let's say you're at the top of the hierarchy tree. Let's say you're Mr. Mark Benioff, Esquire. He's got visibility of every record inside of Salesforce for us. Whereas me, I'm the bottom of the tree. I get to see just my stuff. So if I do a query saying, give me all my opportunities, it's actually quicker to go through and work out, just give me the ones owned by Doug versus Mark, because he looks at everything. So what'll happen, it'll actually work out which way is the best way to approach it, depending upon what the query is and who you are. It then dynamically writes the SQL query on the fly. It then executes that and returns results to you. So if we're looking here then, this is how it works. If you've got low visibility and low filter, so you don't have a where clause, for example, we just loop through and find it. If you've got low visibility as a user, but you've got a high filter, in other words, you put a where clause with an equal sign in it, for example, that will come back and use the filter directly. If you've got a high visibility, you can see everything in Salesforce, but you've got a very, very low filter, there's no where clause, for example, we'll just do a hash join and just come back through the data table and give you all the information. Versus, as soon as you put a where clause with an equal sign in, we'll use the indexes. That's a bit of a hint then, right? If you want to make it go quickly, make sure you use queries with the word with equals in it. So let's get through into actually looking at some of the highly scalable architecture that we currently have. So here's a pictorial view of our data centers. So on the left-hand side, we have a primary data center, and on the right-hand side, we have your failover one. But what we have in each data center is both primary and failover Salesforce instances. So that's a production instance, and that's a failover instance for another. So this one over here is live, that one's live, and that one's live. So let's say this one here actually fails over to that one there, for example, in different data centers. That's how it works. So the ability to actually have an instance group is where you have a bunch of these instances that share some common services. So maybe some encryption, that sort of stuff is stored in that little group. So the instance group is one lump of technology here made up of multiple instances and some shared technology. Each data center has also shared services. So encryption, et cetera, is all shared across the data server layer across there, and that's where we can do the networking across the whole platform, et cetera. So having instance groups gives us lower points of failure, because if we actually have n plus one at least in every instance group, and then we have n plus one in the shared services. We're trying to minimize if something goes wrong with a search, we want to make sure it's only targeted to that little group of instances, maybe just one instance that has that problem. And it makes it easy, repeatable. We can just pump these out really, really quickly, and it provides a consistent runtime environment for your production and failover as well. So failover is identical hardware to your production. Same number of servers, et cetera, sitting there running away quite happily. Now, today what we do is your data is stored in 4 places. Actually, it could be 8, really, if you think about it, because we're using RAID 10 on our disks, so it's really mirrored plus striped, et cetera. So your application servers here are working with your production primary cluster. We're using data guard replication down to a standby cluster as well. So let's say this whole disk cluster goes pop. We'll actually flip down to using the standby cluster over here. And that'll work fine. And today, we use encrypted asynchronous replication at the disk level here between the 2 data centers. And that works quite nicely. It works very well. It provides for great disaster recovery locally when we have a failure in the disk layer, in the database. But it doesn't actually make it easy to fail over to the other data center quickly. So over time, this is the future part of it, we are going to be releasing this replication done at the actual database layer using Oracle's data guard replication up 1 level. And that's going to mean it's much more efficient, and we can do things that allow for much faster site switching. So every new Salesforce instance today onwards, so NA34 was the first one, NA34 has got this, and the rest of them will be rolled out from now on in that same new structure. And we're going to go back and retrofit this to all the prior Salesforce instances as well over the next 18 months or so. And what this is going to provide is a very quick ability to actually flip across to your failover data center. So let's say there's a network challenge between you and your primary data center. So say someone's destroyed that part of the network. You'd be able to actually flip that across. Or if we want to do maintenance, you can flip yourself across to the other instance and keep working on that while we're doing maintenance on the first one, for example. That's going to be coming out as a feature later on. So watch for some output about that in the next 6-12 months. And active capacity planning. What we do is we make sure that we have very horizontally scalable capabilities. So we have more and more servers, we're putting more stuff in them. We don't own our own technology, we actually lease it. So every 3 years, we've got to upgrade just because we get new hardware in the box. We do a lot of work on application performance tuning to make sure it works much more efficiently, and it just makes things fly. So we spend a lot of time making sure that things actually do work. What do we do for you around the edges? Things like Force.com's Apex programming language. So the ability to actually write code in a procedural way is there for you. It makes life easier, and it's very similar to Java, but it's our own version called Apex. You run that on the server. It's one of the nice features that we have, and it just makes things much more scalable and makes things run easily. It's a very powerful language. It allows you to have bulk data manipulation. It does email processing, et cetera, platform encryption, all the good stuff that we have as part of our normal runtime environment. And that's in a nutshell what we do for you as part of Salesforce. I want to give you a very short period of time for questions. My apologies.
Hi, can you tell me where the dwarves live in relation to the application server and the databases?
The dwarves, oh, sorry. Yes, it's interesting. Yeah, I wish we did a lot of dwarves. It seems like we have a lot of gerbils in the background running around making it work quickly. But the way that the errors and that sort of stuff work, it is just an intriguing way that we do stuff. As a technical architect, seeing how we do things, actually, you probably better come outside and scribble it on a board might be easier, yeah, to tell you the truth.